Okay, before I get into the video itself, um, myself as well as Miss Olson and Miss Atwood decided for this unit that we're just going to make our own videos. Okay, so all the videos that you watch for this unit will be done by me. Lucky you. And then Miss Olson students will all watch her videos, and then Miss Atwood students will all watch her videos. Okay, so obviously since you found this video, you found where like the three separate pages are, and the one that says graph videos. Those will always be the videos that you watch. Now, obviously, like if something I say doesn't make sense and you want to try watching Miss Olson or Miss Atwood's video, that might make more sense for you. So if there's something that you didn't fully understand, that would be a really good resource for you to go back and watch those. But since I'm making these, I'll be able to reference kind of what I talked about in the videos, and they'll be able to talk about what they talked about in the videos. Okay? So, learning targets 1 and 2, this is part 1. Learning target 1, identify the features revealed given a quadratic equation in various forms, and then learning target 2, justify the conversion between different forms of quadratic equations. We'll talk more about learning target 1 in this video than learning target 2, but that'll be more for part 2. So the first thing, we've talked about quadratic functions quite a bit the last few days, talking about transforming quadratic functions, whether we're translating them, reflecting them, or stretching or shrinking them. Okay, so I just want you to get a few quick definitions down. Quadratic functions, any function in the family of y equals x squared. So that was our parent function for any quadratic. A parabola then is the shape of the graph of a quadratic function. So we've seen quite a few graphs of these parabolas, and I'm still not any good at drawing them. Sometimes they open up like this. That's a parabola that opens up. Sometimes they open downwards as well. So you can have either one. So go ahead, feel free to pause the video if you need more time to write down some definitions. Next, we're going to get into some key characteristics of a parabola. And we've talked about some of these in class already. We've talked about vertex quite a bit. A vertex is just where the parabola changes direction. It also could be the maximum point on the parabola or the minimum point, depending on which way it opens. I'm going to skip down to direction for just a minute. A parabola can open up or down. That's all you really need to know about the direction. So you're just talking about, does that parabola, that U shape, does that open up or does it open down? The roots and zeros is something that we haven't talked about quite as much. This is basically just where the parabola crosses the x-axis, and that's where y equals 0. And we'll look at an example of that in just a minute. This will also be much more important in later learning targets, where we'll kind of talk about like why the roots and the zeros are even, why do we even care about them, why do we even care about finding them. But for now, all you need to know is this definition. The last one then, the scale factor. We've talked about this quite a bit with the vertical stretch or shrink of the parabola. The scale factor is just whatever you're going to multiply x by to determine that stretch or shrink. So remember, sometimes it looks like that if you're stretching it. Sometimes it'll look something like that if you're shrinking it. Okay, so let's look at an example. In this example, we have a parabola here. It's obviously been moved from the parent function, y equals x squared. So we need to find the vertex, the roots and zeros, the direction that it opens, and then the scale factor. We're going to start with the vertex. Obviously, the parent function is here at 0, 0, so the vertex has moved down here. In this case, for this parabola, it's the minimum point. And that vertex is just, if you just count, the coordinates of that vertex are 5, -2. The roots and zeros, if you look back at your definition, this is just wherever it crosses the x-axis, where y equals 0. So for both of these points, it has 2 zeros. The first is at 4, 0, and the second is at 6, 0. Okay, the direction we just talked about opens up. And then the scale factor is probably the most difficult to figure out, okay? So I'm going to draw in the parent function here. Parent function looks something sort of like that. The parent function has a vertex at 0, 0, passes through the point 1, 1, and then eventually it passes through 2, 4 as well. Okay, but this is what we want to focus on right in here. 0, 0 to 1, 1. So it passes through the point 1, 1, which is just 1 up and 1 over from the vertex. If we look at our parabola here, here's the vertex down here, this red point, it does not cross through this point, 1 up and 1 over. Okay, so that's how we know there has to have been some sort of vertical stretch or vertical shrink. Okay, because it does not pass through this point. It does, however, pass through this point. All right. Notice here we're talking about going over 1 and up 1. So the change in x here was 1, and the change in y here was also 1. Let's look at what it was for this parabola. Okay, so we went over 1, so our change in x is still 1, but the vertical change, the change in y, is 2. Okay, so now we need to compare this parabola to the parent function. Every time on the parent function, every time the x changes by 1, or not every time, but in this case, the x changes by 1 and the y changes by 1. Okay, in this case over here on our parabola, x changes by 1, but y changes by 2. Okay, so that means that we just have a scale factor of 2. Scale factor of 2. If you want to think of it in terms of the transformations we were just talking about, this would be, the vocab we would use would be a stretch, vertical stretch by factor of 2. And remember, it is a stretch since the scale factor is greater than 1. Okay? There is one more thing that you'll need to know, and this is especially true for your before class. You'll notice that every parabola has a vertical line of symmetry right through the vertex. Okay, so this right side here is a mirror image of the left side. Okay, they have a vertical line of symmetry. It's symmetrical right over this vertical line that goes through the vertex. Okay, so that'll be important to know when you come to the before class. So the before class question, how do I find the vertex of a parabola if I know the roots? So for example, we have this parabola with this equation, and then the roots are 2 and 4. Okay, so maybe graph that in your head, maybe think about that for next class, and obviously we will discuss this and go over it at the beginning of class.